Okay, imagine a hemisphere, a half of one. So let's suppose you're standing on the XY plane and you look up and you see this dome on top, this thing right here, this sphere. And let's suppose that's what you see when you look up. And when you look around, you find yourself inside this cylinder that goes up and intersects that sphere. So let's see what this looks like down, on the XY plane. And what we want to do is we want to find that volume, the volume above the XY plane inside this sphere and inside the cylinder, defined by x squared plus y squared minus 4x equals 0. So let's see if we can figure out what that looks like. So I want to try to draw this before we go any further. Now, of course, here's the x-axis, here's the y-axis, and we've got this sphere that intersects down here on the xy plane. And that's when z is equal to 0. So what we've got is 0 equals 16 minus x squared minus y squared. Or in other words, x squared plus y squared equals 16. Well, that's a circle of radius 4. So what we have is, we have something like this. Okay, there we go. X squared plus y squared equals 16. So here it is. X squared plus y squared equals 16. That's what this thing is. Now, so we're inside that, but further we're inside this cylinder over here. Now, let's see what this looks like. So this is on the xy axis, what we've got is we've got x squared minus 4x plus y squared equals 0. So what I want to do is I want to see if I can figure out what is the center of this thing. When I'm talking about a circle, I need the center and the radius. So this is going to complete the square. I had a 4 there, 4 over here. And what I get is I get an x minus 2 squared plus y squared equals 4. And that tells me that the center is 2, 0, and the radius is 2. So we've got a center over here at 2, 0, and it's got a radius of 2, so it looks something like this. Okay, goes on out here. Let me make it in. There we go. Something like that. And what we're doing is we want to find the volume that's inside this cylinder and below the sphere. So in other words, what we're trying to do is we're trying to find this in here, right in here, this business. Okay. So let's see what we need to do. We're going to use a double integral. And so let me get that set up. And our height is the z, so it's 16 minus x squared minus y squared. And I got to determine, well, what am I going to integrate with respect to first? I think what I'm going to do is I'm going to integrate with respect to y first and then x. Okay, so let's see. What does y do? Well, y goes from, we've got, no matter what x is, as we choose an x value, as we go through here and choose an x value, you notice that y goes from down here all the way to up here. In other words, it's going to go from that bottom curve of the cylinder to the top curve. So let's see what that looks like. If we were to solve for y, if I were to take this part right here and solve for y, what I get is y squared equals 4x minus x squared. And that means that y equals plus or minus the square root of 4x minus x squared. So we're going to go from negative 4x minus x squared to positive square root of 4x minus x squared. And of course, x itself goes from 0 to 4. It goes from right here to right here. Okay? So, there's our integral. Now, notice that this region over which we're integrating is circular. So it makes sense that we're not going to want to use rectangular coordinates. We're going to want to use polar. So let's see what we've got here. Now, first of all, if you look at inside this integral, okay, so let me just put a double integral here. This is 16 minus x squared plus y squared. Okay. In other words, I could write it that way. Well, remember, x squared plus y squared is r squared. So really, what we have now, when we're setting this up, getting ready to write it in polar, we've got the square root of 16 minus r squared. And remember, as soon as I go down that road of converting to polar, I need to put an r dr and then a d theta here. So now what we've got to do is we've just got to determine, okay, in terms of polar, what are my bounds of integration? Well, let's look at what we have here. We have x squared plus y squared minus 4x equals 0. So let's convert this to polar. Now, first of all, x squared plus y squared is r squared. X is r cosine theta. So here's what we have. Now, if I factor out an r, I get r minus 4 cosine theta. And that means that r equals 0 or r equals 4 cosine theta. So it looks like that circle up there, this thing right here, can be defined as 4 cosine theta. So if you look at r, if you look at what r does, r goes from 0 all the way up to 4 cosine theta, like this. This is what r does. So I'm going to set up my integral now. This is going to go from 0 to 4 cosine theta. Now, it's time now to determine, okay, well, what does theta do? Well, theta, if you want to trace out this entire circle here, if you want to trace out this whole thing, all of this, what you would need to do is this is one way to do it. You could go from 0 to pi, and that traces out that entire circle. So you have to determine that. And now we have these two integrals, or we have this double integral. We have 0 to pi. We have 0 to 4 cosine theta. And then we have in here 16 minus r squared r dr, d theta. And now our job is simply to integrate that, figure out what that is. So I'm going to start off by just looking at this one. I'm going to say, what if we've got r times 16 minus r squared dr? Dr. So I'm just taking that integral out and seeing what it is, finding the antiderivative of this inside. Well, one of the ways we could do this is to let u equal 16 minus r squared. And that means that du is negative 2r dr, or in other words, negative 1/2 du equals r dr. Yeah, so I could rewrite this as negative 1/2 the integral of, well, u to the 1/2 du. So I replace the r dr with negative 1/2 du, and I replace the square root of 16 minus r squared with the square root of u. Now, at this point, we can rewrite this as negative 1/2, and here we go. We've got, 1/2 plus 1, that's 3 halves. So this is going to be 2/3 u to the 3 halves. And this is going to be negative 1/3 u to the 3 halves. Or in other words, negative 1/3 16 minus r squared to the 3 halves. Okay, so let's see about plugging that in here then. So we've got 0 to pi, and the antiderivative, so here it is. I've got negative 1/3 16 minus r squared to the 3 halves. And I want to evaluate that from 0 to 4 cosine theta. And then I've got d theta left. Okay, so this is what it looks like. And of course, I got all of that, from this bit of work that I did down here. Okay, that. Okay. Now, so let's see what we have now. We have 0 to pi. Now, if I put in, so let's see what we've got here. I've got negative 1/3 16 minus, 4 squared is 16 cosine squared to the 3 halves minus negative 1/3 16 minus 0 to the 3 halves. And that would be d theta. Okay, so let's see what this gives us. Now, we've got, let's see here. We've got 0 to pi. I'm just moving along very carefully. Now, I'm going to, let's just see what we've got here. We've got negative 1/3. Now, I'm going to factor out this 16 to the 3 halves. Okay, so notice all I did was I just factored out that 16 to the 3 halves from the radical. Okay, nothing wrong with that. Then I've got, notice that this is going to be plus 1/3 16 to the 3 halves. Okay, because I've got those two negatives back to back. Now what I can do is I can factor out. Now you realize that 16 to the 3 halves is 64, because the square root of 16 is 4 and 4 cubed is 64. So let me just do this. Let me factor out the 64. So I'm going to factor out the 64 over 3. And then let's see what we've got left. We've got 0 to pi, and I've got negative 1 minus cosine squared theta to the 3 halves plus 1 d theta. Yeah. That's all. Okay, now let's continue on and see what we've got here. So I've got 64/3. Here I've got 0 to pi. And this is going to be negative sine squared theta to the 3 halves plus 1. See? Because 1 minus cosine squared is sine squared. So instead of 1 minus cosine squared to the 3 halves, we've got sine squared to the 3 halves. Now this is going to give us, we go to 0 to pi, this is going to give us a negative sine cubed. Whoops. Plus 1. Yeah. Okay. Now I want to do something here to make things a little bit easier on myself. I'm going to factor out a negative and call this negative 64/3, integral from 0 to pi of sine cubed theta minus 1. Let me just do that. And here's what I want to do now. I want to break up this integral into two parts. Okay, so I'm going to have this. I'm going to have negative 64 thirds, the integral from 0 to pi of sine cubed theta, d theta, plus 64 thirds d theta from 0 to pi. Okay, so all I did was I just split up that integral, sine cubed theta and negative 1. And now you notice what I have. I have two integrals. One integral is very straightforward to solve. In fact, this integral right here is just going to be 64 pi over 3. But this other integral takes a little more effort. So we've got negative 64 thirds, okay, 0 to pi of sine squared theta times sine theta. Just going to use a little trick to integrate that one. And then this one, I've already determined that 64 pi over 3 if I integrate that. Okay, so let's see what we've got here. We've got negative 64 thirds, 0 to pi. This is 1 minus cosine squared theta. I just changed the sine squared theta to 1 minus cosine squared theta. Okay, this is what we've got so far. Now, I'm going to do this. I'm going to let u equal cosine theta. Then in that case, du is equal to negative sine theta, d theta. That means that negative du is equal to sine theta d theta. Yeah, like that. So now let's see what we've got here. We've got negative 64 over 3. And I've got 1 minus u squared. And in place of du, I've got, in place of sine theta d theta, I've got negative du. And then this, of course, I've still got the 64 pi over 3. Okay. Now let's see what this looks like. Let me factor out the negative. I got 64 thirds. I've got 1 minus u squared du plus 64 pi over 3. Now my bounds of integration, notice I let u be cosine. So what I've got is cosine of 0 is 1, and cosine of pi is negative 1. So there are my bounds of integration. Okay. So let's see what I've got now. I've got 64 thirds times, okay, u minus 1/3 u cubed from 1 to negative 1. Like that. Okay, now let's see what happens here. Let's see here. I've got 64 over 3, and I've got negative 1 plus 1/3. See, because when I put a negative 1 in here and cube it, I get a negative, and that makes a plus. Okay, minus, if I put in a 1, I get 1 minus 1/3. And then plus 64 over 3. 64 thirds times pi. Okay, so there's what I've got so far. So let's make sure, let's just look at this. I put in a negative 1, and I got negative 1 minus a negative 1/3 minus a 1 minus 1/3. Yeah, so this works out. Okay, now let's see what we've got here. We've got 64/3 times negative 1 plus 1/3. Now, let me just do this. That's going to be negative 2/3. Okay, so I've got negative 3/3 plus 1/3. That's negative 2/3. Minus, let's see here. This is going to be 2/3. 1 minus 1/3, that's a 2/3. Like that, okay? See? So this is negative 2/3 minus 2/3. Okay, so let's see what this is going to be. This is going to be 64/3 times negative 4/3 plus 64 pi over 3. And this will give us, let's see here, I'll just factor out the 64/3. And let's see what we've got here. We've got negative 4/3 plus pi. Yeah, there it goes. Negative 4/3 plus pi. Or we could, I could go ahead and get rid of that fraction on the inside and factor out 1/3 and get 64/9. And then in here, I would get 3 pi minus 4. Yeah, and there you have it. It's a lot of work there, but we got to the end.